Welcome to the Thunderbolts.info podcast for December 11th, 2015. We're just a few weeks away now from the start of 2016, and I believe that 2016 is going to be a huge year for the electric universe. There are so many things happening now on so many different fronts. I think 2016 could be the game-changing year, to use a political term. We have, of course, the latest scientific papers from the Rosetta mission to Comet 67P. If you follow the space news videos on the Thunderbolts YouTube channel, then you've likely seen the analysis of Dr. Franklin Anariba. His specialty is electrochemistry, and the direct physical evidence now that is available for electrical activity on a comet is, I believe, the absolute best to date. And we have the New Horizons mission to Pluto, which, of course, has just upset all of the expectations for planetary scientists. In fact, searching my mind, it's really hard to think of a significant revelation for Pluto that was in alignment with the, quote, mainstream's predictions. And so many things happening on so many fronts. It was my decision as the creator and host of Space News to begin branching out and to offer some new content to the Thunderbolts audience. Space News is a very topic-specific format. We focus on one topic, and we try to do a really tight and seamless production, but doing a Space News is very time-consuming, and we only cover one topic at a time. And given all of the really interesting figures that compose the electric universe community, it was my decision to restart the Thunderbolts Podcast. You might remember this feature was available in 2012, but we're restarting it now. And this will be a really good opportunity, I think, to sit down with the principles of the electric universe community and speak more conversationally and explore all of the topics that are the most relevant at the moment. And today we're going to be interviewing one of the rising stars. If you follow Space News, then you've recently been introduced to the name of Eugene Bagashov, a speaker at EU 2015. He's been talking a lot about the New Horizons mission to Pluto, and what makes Eugene's research and his contribution to the electric universe community so significant is he's going right into the heart of the fundamental question of the space sciences. Does gravity alone really dominate the universe? Whenever a person is speaking publicly about really complicated scientific issues, the first thing that comes to the audience's mind is, who is this guy? Does he really have the expertise to speak as a, quote, authority on scientific issues? So why don't you begin by talking a little bit about your own background and what it was that led to your interest in the electric universe theory?
Thanks, Michael, for this introduction. As for my background, I have a Bachelor of Physics from Belarusian State University, and then I've studied physics at the National Academy of Sciences of Belarus at the Researchers Training Institute. There I had my master's degree in physics. So I have an education of physicist, but now I'm doing my PhD studies. But my research field is more in theoretical physics, studying quantum field theory, in particular quantum chromodynamics, the theory of strong interactions. So I'm working with theoretical physics on a subnuclear level. But I find that my general education allows me to tackle a lot of other stuff that's going on, and I have access to some of the journals. I read papers often, for example, papers on Rosetta mission and about Pluto. So if any topic interests me, I just do an independent research of sorts, and I try to find any EU relevant stuff there. And as for the question, why do the EU interest me? I've actually always been interested in space since my youngest years. But then around 15 years old, it just came to stop because, I thought, I already know the edge of science because I read a lot and nothing excites me. And it's going to be, decades since something new would be known, because we are limited by the velocities. We cannot get to stars. So my interest kind of waned. But a year and a half ago, I've stumbled upon Ben Davidson's Suspicious Observers channel on YouTube. And he gave a lot of references to the Thunderbolts channel and Symbols of an Alien Sky movie. And I've watched it and was shocked, absolutely. This paradigm took almost all of my attention at that period. And I've started researching like crazy and watching all those YouTube videos from Thunderbolts channel. Well, I think this is a pretty regular story among the proponents of the EU theory. At least I've heard a couple of times something similar when I spoke to people at the conference at EU 2015 in Phoenix. And by the way, I want to just say thanks to all the people from the community because I've got so much warmth and readings and the meetings with people. And I want to say thanks especially to Susan Sherratt and Dave Talbot. They were very kind to me, and I haven't expected such a warm welcome in Phoenix. It was warm in all senses, it was very hot in there.
Yeah, the thanks will be well received. It's interesting because you have the more conventional educational background. I'm wondering, when you came across the electric universe theory, and you say you were introduced through Ben Davidson's channel, then you come across Symbols of an Alien Sky, you're becoming aware of these radical theories, the idea of recent chaos in the solar system and the idea of incredibly intense electromagnetic interactions between planets, and the idea that gravity is not the dominant force in the universe. The universe is pervaded by conductive plasma, and you have electric currents flowing along the arms of galaxies and electric currents powering stars. These are considered extremely radical ideas, but did you come across anything in your consideration of the electric universe theory that you would call like a fatal objection? Obviously, no theory is going to be perfect, especially in its early days of development. But was there anything that for you was a big red flag and just said, well, no, the people who are arguing for this are doing fringe science and it's not worth my consideration?
Well, there were a couple of points. For example, I've read Velikovsky sometime later after I was already familiar with the Thunderbolts channel. And he had ideas like, for example, the spin of the Earth would be changed. I mean, when Venus passed by, the Earth started rotating backwards for some time. For me, as a person who knows theoretical mechanics, at least from the standpoint of the current theories, it is basically impossible if you would make such a radical turn of the rotation of a planet in a very short time period. It would most likely be destroyed because of the inertia. Other than that, I only had numerical problems because, for example, for something like a Great Canyon to be excavated by electric pulses, it would take really high amounts of charge and current and voltage. So it's very hard to believe in. I'm not saying that it is a flag or something. It's a hardship that should be evident for everyone, I think. But other than that, there are some ideas here and there that might sound contradictory, but core ideas of the electric universe, like how the galaxies behave, how the galactic clusters behave, it doesn't look impossible to me. Electricity is the most powerful force in the universe. If we talk about large distances, we're not talking about nuclear physics, but then again, it might be electricity that governs the nuclear interactions, but that's another topic. But on large scale, the electricity is the most powerful force in the universe, and it's much more impossible, I think, to consider that gamma ray bursts or something like that are caused by gravitational accumulation of energy, because that would take a really impossible amounts of mass, gravitation, etc., etc. And
Right.
we get these ideas about black holes and other really, really wicked stuff. I think this should be considered a flag, as you said.
The red flag, yeah.
Red flag, yeah.
Now, in some of your earliest space news, you were talking about the New Horizon mission to Pluto. In fact, you made some predictions, I think, that were interesting, and I don't know how many of them have quote panned out or could have panned out based on the technology that was available on the spacecraft. But I'm sure you've noticed that all of the headline grabbing discoveries in the Plutonian system have come as a surprise for the conventional story of planet formation and the history of the solar system. we see these unexpected features. For instance, on Pluto, we see sand dunes. We see on Pluto an unexpectedly low number of craters. We see deep chasms and trenches on some of the moons. There are two double-lobed moons in the Plutonian system. I believe it's Hydra and Kerberos. And so these are highly unexpected discoveries. So what are your thoughts on just the basic ideas about planet formation? Do you think that the electric universe theory, for instance, of the electrical capture of planets, is that a theory that has potential validity to it?
Yeah, I think that this idea that, for example, Pluto and maybe other objects in the solar system could have been satellites of some other planet that passed through or was also captured, like the Saturnian theory that Earth was once the satellite of Saturn and was captured by the sun. I think it is a good alternative framework in contrast to the nebular hypothesis, a good alternative framework to construct a coherent theory to compose the observational data into it's like a skeleton to which we attach what we know, and I think it works fairly well.
Uh-huh.
And it has some evidence, for example, the one that I've mentioned in the latest space news with me on Pluto about the atmospheres. For example, that we have a couple of groups of planets with atmospheres with very similar composition. Like we have this nitrogen group, Pluto, Triton, Titan, and Earth have a nitrogen-rich atmospheres, and it looks pretty messed up. For example, Mars, Callisto, and Venus have carbon dioxide atmospheres, but it's very hard to believe that something like that was created by gravitational or centrifugal division of elements. So probably some chaos was there. And this idea of capture works here fairly well because there should have been chaos when some other planet or even a brown dwarf star passed nearby. That's where we could get this cratering, and when the asteroids and comets could have been torn out from the rocky planet surfaces, as the electric universe proponents state. And really, a lot of new discoveries say that there are inconsistencies in the nebular hypothesis.
Sure.
For example, we find stuff on comets that could have been formed only in a high temperature environment like olivine and other minerals like that. But at the same time, it is frequently stated that, the comets were formed really far away from the sun, so the temperature was really low, etc., etc., and just doesn't work.
Yes. And so, Eugene, I know that you've been following the Thunderbolts Project's discussions of the Rosetta mission going back to well before the landing of the Philae probe. And you're familiar with the electric comet theory. And I know that you have followed the analysis that Dr. Franklin Anariba has offered of the most exquisite direct physical evidence of electrical activity at a comet. So I'm just wondering, what are your thoughts on the success of the electric comet theory in terms of anticipating these endless surprises that have been revealed by the Rosetta mission?
Yeah, well, here's a couple of points. I think that the mainstream idea about the dirty snowball, it's still alive only because of the inertia of thought, because people just find something new and find something else, but they don't question the paradigm. So it survives no matter how much of the contradictory material is accumulated. But they have developed some of the answers, we might say, to the stuff that was observed. For example, as for the hardness of the comet's surface, that the Philae lander bounced from it, they weren't expecting such a hard surface. Actually, there were fears that the lander might just be buried in the comet's fluffy snow when they were designing the lander. So yeah, but what they say about this hardness is that, well, probably it's because the ice gets what they say sintered. So it kind of melts a little bit, but then gets fused and it gets much more strength than it was before. So that's how they answer this one. But in general, I think that the EU paradigm really works well with this case because, for example, There's actually a lot of observations that support this, but I might just name a few. For example, the concert experiment that was conducted with the Philae lander and Rosetta orbiter, they were basically probing the comet's interior with the radio waves, very long radio waves. And what they found was that the comet is mostly, well, it all is based on some of the assumptions, but still the conclusion is that the comet is 70 to 85% void. So it's porous to such a degree that it's almost 80% void. But that means that the material density is much higher. You know, that the average density of the comet is something like 400 kilograms per cubic meter, which is almost twice as low as water ice. But if it's so porous that it has 80% cavities inside, then the actual density might be, I don't know, I haven't calculated this, but I don't know, maybe 2,500 kilograms per meter, which is fairly close to the rock density for the density of asteroids. So this is just one example. And as for the strength of the material, I mean, the bounce of the Philae, I remember Wal Thornhill said in one of the videos, I think it was Space News before the Rosetta approached the comet, maybe in August, I'm not sure. But I remember literally Wal Thornhill said that they might underestimate the rockiness of a comet. And what do we got in the end? That the lander was buried somewhere under the rock, you know, somewhere in the shadow. I think this is a really good, if not a full confirmation, but at least everything that EU was stating, it was fulfilled in this sense.
Uh-huh.
It turned out to be true. And another thing is that, for example, when Philae was landing, when it was dropped from the Rosetta probe, they were trying to measure the electric potential, and their measurements was spoiled because the reading was saturated. Well, I'm not sure of the particularities of this experiment, but I might give you a reference. Anthony Letellier, he was one of the people from the Sesame PP experiment on board the Philae lander, and he said that when they were trying to measure the electric potential during the descent stage of the Philae landing, the measurement was saturated. I'm not sure what this means technically, but I think this is something that no one was expecting, you know.
Right.
And the other thing that was detected was that the Rosetta probe itself had detected a monoenergetic beam of electrons coming from the comet on multiple occasions, and that was, I think it was in an energy range of a couple of hundred electron volts. And what this means is that since it's monoenergetic, it means that there's no spectrum per se. There's a very thin band of energies. And this means that probably it is because the electrons were accelerated by electric field. And this electric field, if they were accelerated by it, there was a couple of hundred volts between the comet nucleus and the probe. And I think the distance was like 10 or 20 kilometers at that time. So I remember that EU proponents have long stated that the comet bears a negative charge, going out in the far reaches of the solar system where the positive influence from the sun is attenuated. There's a much higher negative influence, negative potential. And so the comet accumulates this negative charge. And again, I remember there was a recent paper on the observation of negatively charged dust grains on
Yes.
the comet. So I consider this as, again, a direct observational evidence for the electric universe paradigm, well, at least in the cometary section of it.
Good. Well, Eugene, it's been lots of fun here. As I said at the beginning, you're a rising star within the community. So I know that the members of the Thunderbolts Project's YouTube subscription base and the people within the community, they're really excited to have seen your addition in the last year or so. So we're going to stay in touch with you. We want to bring you back as a Space News guest and a podcast guest just as much as we can. And so we like to ask you to just keep your eye out. Keep your eye out for any news items and other developments that you want to talk about, and we'll be happy to hand the microphone over to you so you can give your 2 cents to the Thunderbolts audience.
Okay, thank you very much. It was a pleasure talking to you. And again, I want to say thanks to the Thunderbolts Project and EU community in general. Thank you all, guys, for being out there.
All right, thanks a lot, Eugene.
Yeah, thank you.